Thank you. Thank you so much. Sorry, I didn't do an AI talk, but I thought that we should wait a little bit to see the real things we're doing with AI. But I thought, we're at a moment that we're getting a lot of consumer devices out there, and I wanted to look backwards, right? This history of what I've seen has happened through the different eras, and I would classify them in these three. The systems research part, then this era of the wonders of VR, and now I feel like we're in this, how can we make this usable? At least for a bunch of us in research. And I've been working for a decade in industry, and before that I was in academia also for a while. I published quite widely on scientific venues, and this is the first time I come to a consumer show. So actually it's been more than 2 decades, right? Like Ivan Sutherland was doing the Damocles sword already in the 60s. And later we started looking at the wonders of VR as soon as we had minimum viable systems, right? And Jaron was one of the pioneers, right? The first startup ever with a headset. And in the 90s, there was a proliferation of headsets. There were a lot of them. And this year in IEEE VR, they had a collection of them that you could check. But I think it was when we first saw the DK1 arriving to consumers that we started perhaps thinking, now you're not longer going to need the experimenter, just people open the experiences by themselves. But the truth is that it is quite hard to click a button in VR. So I'll do a bit of a history talk of, I think many people who came into VR came from systems originally, so we were breaking cameras and putting them together with things, perhaps measuring the latency of a system, and doing pass-through back in the day even. So these things, in a way, have been explored for a while in research, all of these ideas that you can interact with other people also. And of course, one of the interesting things is that you can interface between yourself and reality, and then you can augment the human, right? So virtual reality and augmentation go very much together. So we did, for example, a tool that could use a camera to detect your heart rate on top of a HoloLens, and we could just see what your heart rate was, right? So. Over here, this is the 2 ways we can do it. And when you're talking to someone, you would just see it overlay on top of the face of the person, right? So it was also context aware of the environment in which you were, and sort of overlaid, right, like this. But we had a problem in general, which is in research, we try to publish papers, and it's very hard to publish papers that are only system papers. So we started looking more about, okay, this is the system that we build, but what are the fundamental learnings that we are uncovering? And this is basically my PhD. My PhD, I started with the fake spade. So that was the device that was available then. And we were building real-time mirrors. I think that was kind of one of the first mirrors that were built and sort of distributed. There were people, for example, at ICT here, who open source already this sort of cardboard predecessor. And by the end of my PhD, we were using these NBs devices that were almost military grade, right? The whole idea was that, we have this system that can interface with reality. What are the wonderful things we can do apart from building the system, right? Like we have already minimum systems that, and one of the very interesting things is that you can create embodiment over an avatar. So now you're a different body. It has this kind of one-to-one substitution to your real body and has very interesting effects on the behavior of the person. It can affect your distance compression. So normally in VR, when you ask a person to walk somewhere, they will underestimate the distance. So 10 meters, they walk for 8 meters. They will also perceive touch differently if they have a body or not. And embodiment plays a very strong experience difference between people having the same experience will have a very different behavior depending if they are embodied or not. And ultimately, you'll
either gradually or instantaneously.
You'll end up with things like you start following your avatar, right? So you feel like very attached to the avatar. So we explored this avatar embodiment very widely, how to create it, the effects, how to measure it, how to break it. And eventually, most of my PhD, for example, was on this idea that very neuroscience of, oh, can I measure it in different ways? So there is a lot of measures that have been happening in how can we detect these experiences, presence, embodiment, etc. And then we figure out that people wouldn't want to have the EEG always recorded. So mostly we propose questionnaires. I don't want to enter into particular detail into these whole neuroscientific experiments, but you can see that there are wonderful things you can do with embodiment and with avatars. That one of the wonder of VR is this realistic behavior that you achieve because you have this illusion that you're in a place and that the things that are happening around you are plausible. So you start having like heart rate acceleration, etc. And more importantly, you even have realistic reactions when interacting with avatars. How the avatar looks is also very interesting, very important. People will eventually perceive their avatar as their self. These are brain images here. With electrophysiology, we can see how the dotted line is the self picture, and the dotted line here is the self avatar. And you can see how there is a depression compared to any other image or any other avatar you see. So you're self-recognizing yourself in avatars. But more importantly, we've seen that it's more important that the avatar looks alive and it moves correspondingly. And then you can find things like effacement illusions, which can be measured in different ways. And you'll be saying like, oh, these avatars feel like very far away. Well, all these experiments really drove us to testing this in actual products that you use today. And this was one very early prototype of having avatars inside Teams. And we ship it for 270 million people that are one click away from using avatars. If you're users of Teams, you can use that. And I try to bring avatars all over the place. So I have a bunch of libraries that I published, including for synthetic data for self-driving cars. But the wonders of VR don't stop in avatars, right? You have all these other things you can do, from haptics to locomotion to audio, etc. So here an example.
We have a beacon set for Nike store, 248 yards.
The beacon has been helpful in approaching different addresses and places in busier areas.
I'm getting the bell right about here.
Great. So let's just head off that way.
Okay. Forward.
So I wanted to start with this very particular example of a low vision person using an augmented reality that is very much focused on spatial sound and embedded in the real world. I think a lot of the experiences that we're going to create are going to be very blended with reality. And the case of GPS is very interesting because we have created a GPS that is very turn-by-turn navigation. And this kind of GPS is more allocentric, right? You have the sound coming from a particular position in the distance. And you can have all sorts of examples of how you are going to predict changes, and it's not turn by turn, but you can play around how would you do this sort of auditory experiences with a combination of both. Haptics is also another very interesting area where you can do things like
space in which the action unfolded.
Motion retargeting is something you can do inside virtual reality, in which a person is moving in one direction and you move their avatar in a different direction, and then they reach a different destination from what they originally intended. And so this way you can reach virtual targets to have haptic experiences. You can also do it with vibrations on the controllers, create haptic illusions that you're being touched in different parts of something you're holding, etc. But the reality is that if you really want to create good experiences with haptics, you'll end up having a controller. And so we explore this, and the idea of haptics, I think, ends up in this dichotomy that you either have a glove or an exoskeleton that replicates your hand, or you're building controllers that replicate the properties of the objects. So we went mostly for the second option, which ends up in something like this, right? You're grabbing things in VR, and wouldn't it be nice if you had that experience also in virtual reality? And so we did all sort of prototypes, also for tabletops, where, it's very, oops. Let me just start it this way. So the whole point of haptics is that you only need it where your hand is, right? So you could move moving things around and have shape displays that are operated near your hand. Sorry. And so we've been playing with haptics for a while, and it's all another part of the wonderful things that you can do inside VR. But the truth is that so far we haven't really made it usable. And so you enter this paradigm where the user is inside the content. And until now, the content was inside the screen. But now you have the user inside the content, and the interactions that you've been using until now might not be so transferable, right? It's not a one-to-one mapping of what you were doing works here. And we have focused a lot on embodied interaction, right? You're going to go there, you have this hand tracking, this one-to-one mapping, but you end up with poor performance. And to be honest, if I'm bad at tennis, I don't want to go to VR to be bad at tennis also, right? So how do we fix this, right? So one of the things that you can do is decouple the motions of your body from the avatar. And so you can even have this very fine-tuned option, and here you can see where the actual hand of the person is, where the actual avatar hand is, because we are correcting it, and people do not notice because they continue having the whole agency over that avatar, right? So you end up correcting, and you hope that with things like the follower effect that I was showing before, you might actually learn to do it better. And you can end up having things like this that work perfectly well. So you're totally dissociated from your avatar, from your action, but this person is not really paying attention to, it's fantastic for learning because you can reduce the complexity of the task. Right now, you only need to learn this part. You don't need to learn the accuracy of this other part, so you can decompose the problems. And actually, we have a lot of composed problems in VR because the input we really get currently is very limited. We might know where the head is, where the hands are, and we have to extrapolate the full body. This is one of the projects we did to try to fix this. We reconstruct a whole inverse kinematics, and then we search for each of the joints on a database that is very tiny. This all works real time. And then what we can do is that sometimes if you have a high score on the database, you retrieve from the database, and if not, you just go back to the inverse kinematics. So you end up having a lot of motions that can even extrapolate from what you have in the database, but you can create databases of emotions and just alter how the person is behaving, but you still remain with full control of the one-to-one, right? So one of the things here is like, how far can you go before, and we do a lot of hand reconstruction, and it's pretty good, actually, with the database. So how far can you go with this idea that you reduce the
Virtual
avatar thing.
reality enable users to possess a virtual body beyond their physical.
So here we have the avatar we saw in the beginning, and it's great, but another additional problem is that generally when you're interacting with objects, you just pass through them or they pass through you, and this is very annoying in VR. So how can you solve this? From this perspective, you could just apply the physics to the virtual body, and you don't care if your real hand actually is far away from the real, from where the virtual hand is, right? And we found that people actually really prefer an avatar that behaves with physics, and it's not one-to-one map. They would feel more embodied on it than if you're just trying to just map the one-to-one of the person. And this is important because if we only have embodied input, we're very limited by the body. And I think we have to think of it very differently, like a multimodal input, right? So we still have this problem that we cannot click buttons inside VR. So I've been with precision. So I've been trying to solve this for a little bit now. And we just put this paper, this is, it's kind of like a magazine, very accessible writing on guidelines of productivity for virtual reality. And so here is the pickle, right? Like we want to interact naturally with the virtual world, but if we put things too close, we're claustrophobic. And if we put them too far, we cannot have direct interaction, right? So then you have to have this limit of what's reachable. And there is really a very small, comfortable space of visualization and close range interactions of 20 centimeters. You really want to have much more than that. So your only other option is to start thinking of different ways to do inputs. And number D is apparently what's been a general solution for until now, which is the hand ray. We recently have seen number E, which is gaze and pinch. And of course, B, which is the direct interaction. But I think there could be many, and this is just a matter of combinatoria. So we'll end up having this idea that there are some inputs that are implicit, some inputs that are explicit, and in the end, you just want to have these three parts of an action, which is you select something, you confirm it, and then you provide feedback to the user, right? So we're trying to figure out what other ways you can have precision input to interact in virtual reality. For example, one example of implicit input with intent-driven interaction.
Smartphones and watches can provide an always available.
So here you're interacting with a device, and when you're looking at the virtual world, you are interacting with the virtual world. When you're looking at the device, you interact with the device, right? So you can have these sort of paired devices and have much more nimble interactions, right, between the devices. So you can basically know which one you're using, and then, like we were saying before, now I'm looking at the phone, and now I'm not looking at the phone anymore, and I can use it for interaction, and we have open sourced this. Examples of multimodal interaction. Well, the good thing about the multimodal interaction is that you can divide the labor. Something is very good at, for example, gaze is very good at seeing things that are far away, so it's like a perfect ray, much better than the hand ray. You can fixate on something much better than you can like hold your hand, not move, pinch, right? Versus, well, you can pinch without much faster and do a confirmation. So, but then you have these problems that you need to unlearn some things that you have learned of how you interact, and then you can have problems with triggers that are late because you have two modalities, etc. And so I think in general, we're all exploring this idea of how do we really make it usable, right? And this is also coming this month in computer graphics and applications. It's just design principles and challenges is very consumable. And I think part of what is important about how we make it usable is that it's not just my job to make it usable. I think it's the job of everyone. And so the role of open sourcing is very big. It's something that I carry from all my years. from avatars that I've been open sourcing.
Realistic avatars are an essential component for creating social interactions in virtual reality. However, the main issue faced by small labs is a lack of simple self-creation animation tools. In this paper, we present MoveBox, a plug-and-play toolbox that aims to provide resources for motion capture and animation.
So all of these tools are available. They are super easy. The quaternions are done. And they were the ones we used to do all the experiments we later did prototyping for teams, right? So, you can prototype pretty serious stuff with these things. And I've continued doing open sourcing even now, right? More avatars, things about the example I was showing of the intent thing about the screen sharing, etc. And with that, I'm gonna finish my talk giving thanks to a lot of collaborators I work with. Yeah, that's all for today.